Sagar, can you hear me?
Yes, I do. Sorry, what happened? Any problem with the audio?
No, no, I was just checking because I couldn't
Ah,
hear
okay.
anything. So
No, no, I was actually starting the recording. So, okay,
got it.
great.
Yep.
So, the topic for today is dynamic trunking protocol. A simple topic, but might be you guys need to know from the CCNP and CCI point of view. So that is why I'm trying to cover all the in and out about DTP, dynamic trunking protocol. Okay. So what is the usage of this? What is the way to configure this? And what is a possible attack if you don't take care of DTP? So that is what something we will be discussing in today's class. Okay. So first thing first, what is the advantage of DTP? Or what does DTP is all about? So let me make use of this. So I'll just write down few of the key points for a DTP. Okay. Uh, First thing, it's a Cisco proprietary. Okay. That means Cisco have discovered this, and Cisco, we can see this particular layer 2 protocol running on a Cisco boxes. Okay. Now, what is the purpose of having DTP, or where do we see this? So let's say I have two interface. Let's say I have two switch A connected to switch B over on a link. Okay, just a cable. So let's say we have not configured anything on this switch port. Okay, and by default this DTP will be running, or this will be enabled on these boxes. So what happens is, by default they are going to negotiate. Automatically the negotiation will happen, and then they will start forming trunking. Now that is an advantage of DTP. You don't have to go and manually configure something on these interfaces. So basically, how do we configure any interface on trunk? So we go to the interface command, we type giga ethernet 0/0, we go and type switch port trunk encapsulation. So we know that there are two protocols, one is .1q or ISL. We go to switch port mode trunk, and then we allow the VLANs within this interface. Okay, so this is a way to configure this. Now let's say I just want to eliminate this process. I just want to eliminate the process of configuring each interface. Don't worry, you have your DTP running on your switches, which will negotiate. As soon as you bring up the two devices, they will negotiate and they will form the trunking. So this is a plus point of having DTP. And Cisco has this enabled by default, but yes, you can turn this off and you can change the behavior of this DTP. So this is something which we need to know from the advantage point of view. Now regarding to the timers, every 30 seconds a new DTP advertisement will be sent. Okay, so this will be only checking whether the next device is up or dead, and what is the status of that. Let's say if this is down, then your uh, trunking behavior will be getting disabled. Okay, so in simple word, let's say I have two switches, they have DTP by default running. Okay, they form a DTP neighborship. So every 30 seconds a new advertisement will be advertised from both the side, just to make sure whether the devices are up and running. If they are down, then your DTP table will remove that from the end, from its table. Okay, to have that updated entries here in the DTP table, we just send the DTP keep alive or DTP hello packets, just to make sure that two switches are up and running. Okay, now regards to DTP and VTP. Now, if you guys are thinking what is the difference between DTP, VTP, so let me tell you. VTP is a concept to propagate your VLANs. Okay, so let me draw one network diagram. Let's say I have a switch A, and below the switch I have multiple other switches, something like this. So what is the advantage of VTP, VLAN trunking protocol? We just need to create VLAN on one end, and rest the VTP advertisement would be taking down to all other switches. So what's going to happen here is all this VLAN will be automatically getting synchronized with the other switches. We don't have to manually configure VLAN 10, 20, 30 across each one of them. Now when we talk about DTP, DTP is not with regards to VLAN propagation. Okay, it's not about VLAN propagation. It's about the trunking behavior of two devices or two switches. So let me draw the same diagram once again. Okay, so let's say this is A, I have B, C, D, and E. Now what is DTP? DTP is nothing but DTP will be running across on two switch port, and it will just enable the trunking. What is trunking? The meaning of trunking is to allow multiple VLANs. Okay, so your DTP, what it does is it's going to negotiate between two interface, and then it's trying to convert this interface into trunking. So every switch port, the DTP will be pre running, and it will negotiate and it will try to make it as a trunking. So you can see the trunk behavior across on all of the interface and some. So this is a difference. This is a basic difference between a VTP and a DTP protocol. Both of them. Okay, 1 second. One second, guys. Okay, some strange thing. My tab started malfunctioning, so I cannot be able to use the pointer. Okay, so not an issue. I'll just try to explain over on this. So that's a difference between a DTP and VTP. Okay, now coming to the next point here. So your DTP doesn't have to be configured. It is automatically present on all the switches. And the main purpose or the main usage of DTP is plug and play. That means you don't have to configure any trunking manually. So as soon as you connect two switches, they will automatically negotiate and they are ready to be tested. Okay. So if I have one device here, one switch here and another switch here, I don't have to manually configure something. By default, the trunking will come up and I'm able to test my behavior. So I can allow multiple VLANs. Okay. Okay. Now regarding to the mode of DTP, there are three major modes of DTP. The first one is called as trunk. Second one is called as dynamic desirable. And the third one is called as dynamic auto. So we know what is trunk by default, right? We know how to configure a trunk or a access port. Now what are these two things? What is the role of these two things? Okay. Now let me tell you, let's say I have two switches connected next to next with a cable. So from this point of view, from this switch point of view, we can see any they in any negotiation form. Okay, so there will be different negotiation enabled on this interface. So let's say this is a giga 0/0. Now I can see some negotiation kind of auto negotiation. Okay, we call it as negotiation auto. We will also see some devices, some switches where the negotiation will be turned off by default. Okay, it will be with the command no negotiation. Similar way, we will see some devices, some switches where the DTP will be enabled with desirable mode of negotiation. And there will be some devices where we see them to be auto negotiation. Okay, so as per your Cisco devices, it can be any family. Let's say for a iOS or XC or any kind of a switch family. Okay, we can see this behavior. Also it depends on your, like, the model or the release of your model. So let's say if a switch is pretty older or it's something which was launched in 90s, so the behavior might be different than the switches which are launched just few years back, might be in 2015. So depending upon the model or the manufacturing date, these things can be changed. So let me show you on a lab directly. Okay, so let me give you the example what exactly I'm trying to say. So I have one switch here. So let me take the console of this and let's see what kind of negotiation does this uh, device has. So as you know, there are multiple possibilities. It can be auto, it can be no negotiation, it can be desirable, it can be auto negotiation. So let's see from this lab setup what we have here. So meanwhile, I'll just start the other two so that we don't waste time on the booting process. So this is one model which runs on viOS L2 software. Okay, and I want to show you what is the negotiation or what is the DTP by default configured on this particular switch family. So how do we see is, just go to show interface Giga Ethernet. I want to see this particular interface as of now, okay, which is connected to one more switch. And similar way, I will also show you. I will also show you of this interface 1/0. Okay, it will probably not give me the proper output, so I'll make use of switch port. So when I do that switch port command, I can see that by default my interfaces are negotiating. They are not turned off, they are negotiating, and they are negotiating in one of the mode called auto. If I go back, so right now this switch is by default on this auto negotiation, on auto. Similar way, if I show you one more device, another switch from another iOS family, this is also a Cisco box, but this will have a different behavior at this moment. Okay, so it is also negotiating, but it is negotiating on a different negotiating protocol. Okay, so as of now the second switch is on this. Now what is the problem of having a mixed environment? Okay, so they are all good, they are all good, only the catch is, I'll tell about the modes. Okay, so before that let me show you one more thing, then I'll tell you what happens here. So right now I have not done any trunking. Okay, I have not gone to any interface. I have neither configured any VLAN or neither encapsulation.1 or anything. But let's see if the trunking is being enabled or not. So we can see the trunking has been automatically enabled between these two things. So we can see the trunking is automatically enabled even though I have not done anything. Let's see from switch point of view. So let's see show interface trunk. So when I do see show interface trunk, that is also showing to be in a trunking pair. Just a minute. So from this switch point of view, this is in a trunking neighborship with this switch. Okay, so we can see it's been trunked 1/1. Now let's see from this switch point of view, the second switch point of view, show interface trunk. Okay, so this has few trunking enabled because we have configured on them. Okay, so if I show you the configuration, so they have some configuration by default running. So if you show you this interface, so you can see there are trunk enabled. So let me first clear the configuration. Okay, it will take 30 seconds for the new for a new DTP advertisement to been sent and then take down the entries. Okay, so your updated DTP table will be always getting refreshed every 30 seconds. So let's see show interface trunk. So it's getting taken down one after one. Okay, so this should be going down. Okay, so let's say show interface trunk. Okay, so looks like this is some dummy value. Okay, basically once we disable the trunking, it will go down, and there is no relation between this switch and this switch. Okay, there is no trunking enabled on 1/0. These are all random interface, some with some other switches, which will go down gradually one after one. Okay, so now my point to show this particular topology is we see that trunking was enabled as soon as I got these two up, but the trunking is not up between these two switches, right? So there are different types of mode and there are different type of outcomes out of this. So let me tell you what happens here. Okay, since my pointer is not working, I'll just show it directly on internet. Okay, so let's talk about this. Okay, so on one side of a switch, if I have dynamic auto with another dynamic auto on other side, they are going to be access in nature, and that is what is happening over here. So over here I have by default dynamic auto and I have dynamic auto across here. So they are not going to form a trunking between this. They are going to be access port. So I can show you that by the command show interface giga ethernet 1/0 switch port. So if you see this, they are dynamic auto on one side, and what kind of operation mode are they entered to? They have gone to static access. They are still negotiating, but the thing is, the other side is your switch 7, the squad switch 7. So let me rename this to squad switch 07, and if I show you the interface 1/0 switch port, this is also dynamic auto. So when you have two dynamic autos, by default they are going to fall under access port. That is what is happening at this moment. On both the switch I have dynamic auto, and that is why I see it access. Now on the other pair of switches, that is between this, which went to the trunking mode, let's see what happened actually there. Okay, so on the one side I have dynamic desirable, and on other side I have dynamic auto, and what is the outcomes? It is trunk. Okay, so let me show you from this point of view. So let's see this switch. So when I have this switch, if I make use of show interface ethernet 0/0 switch port, they are on a dynamic trunking, they are negotiating. Okay, and on other side it's switch 7. On other side is a dynamic auto. Okay, so dynamic desirable, dynamic auto is going to become a trunk after all. So that is why we see the trunking mode. So this is all good. Only the concern is when I have two dynamic auto falling next to next, or in a friend to friend or a point to point way. If I have dynamic and dynamic, then that's going to be a problematic situation. Okay, where the link will never come to a trunking. It will be in a access port. Rest all behavior is good with us. Okay, dynamic auto with desirable, dynamic with trunk is also okay. Okay, now let me tell you the different ways we can configure the interface. So we are aware of switch port access and trunk, right? Now these are two configured manually. We do configure them manually across the interface. And today we learned something about auto negotiating and getting configured. So that is called as dynamic auto and dynamic desirable. Okay, and basis on this table they get either access mode or either trunking mode. Okay. Okay, so how do we change the behavior? Let's say when I have these two switches where trunking is not getting up because they are a part of dynamic auto by default, I can change the behavior. Okay, so let's say if I make it trunk, then yes, a trunk and dynamic auto will negotiate. Agree? A dynamic auto on one side and a trunk on second side will be a trunk. Now let's say I can also make it as a dynamic desirable. Now that is also a good result, a trunking output. Okay, so let me show you by doing both of them. So let's say first I go to the switch 8. So let me show you what is a switch port of 101/0. At this moment it is a dynamic auto. So let's change the behavior of that. I go to 1/0 switch port mode dynamic. If I do a question mark, I see it can be either auto or it can be desirable. So at this moment it's already auto. I'll make it as desirable. Okay, so once I make this desirable, I can go back and check once again. It's now under desirable mode and the trunking should be showing up. Okay, so if you see now we have 1/0, that is nothing but this side, this interface, which is auto negotiating with your second switch. So now we can see a trunking over here because you change that auto behavior to desirable behavior. So it doesn't mean that you should change, you need to change on this side only. You could have changed at this part also, but I just preferred this one. So it can be done anything. Okay, it can be either on the switch A or on the switch B. The only thing that you need to remember is this table. If it is both auto and auto face to face, if they are going to be auto, then they will never be a trunk in nature. Okay, so let me show you the output details here. So if you see this trunking interface output, so it says that at this moment the DTP mode is desirable because the negotiation is between auto and a desirable, and it has selected desirable as a mode of negotiation. Let's see from the second device point of view, that is from this point of view. Show interface trunk, and on this side it has taken up the auto configuration. Agree? On 101/0 I have auto, and on the switch 8 I have it desirable. That is what I have configured. Under encapsulation, if you see, by default it took as negotiating. N is nothing but negotiation between ISL protocol. So we all know trunk have two protocol. One is .1q and the other one is ISL. So what is the behavior of a .1q? It carry 4 bytes of header, whereas ISL is going to carry 26 byte of header. If you see from this, what has been the result? It's been ISL. Now that is a drawback of keeping a DTP. Agree? When let's say you just explore the advantage of having DTP, that it's a play and plug. As soon as two switches come into neighborship, they will form DTP and a trunking will be enabled by default. But the drawback is by default they are going to take ISL. Now what happens is you can your payload or your data bit that is flowing across this interface is getting reduced because ISL is going to take more a large number of header, whereas what is preferred from the network point of view, it is always .1q, right? So the most of companies, what they do is they don't enable DTP. Okay, they turn off DTP. because if I turn off DTP, I can manually enable trunking. So let me write it here. So I can manually enable trunking wherever I need, and I can make use of .1q header, right? I don't have to go and fall into this auto negotiation of ISL, and you know the drawback of having ISL. Okay, so this is trunking, the native VLAN one, and rest of what interface it starts showing you. Okay, now how do we disable the DTP negotiation? So if you see the output of the interface, by default they will have some negotiation enabled. Okay, so because of this negotiation, the DTP will start listening or start broadcasting on either desirable or auto. Okay, so as I told you earlier, the interface can be working on different behavior. You will have some negotiation enabled by default. If the negotiation is enabled by default, depending upon the devices, it will be configured on desirable or it will be on auto. Okay, similar way some devices will have no negotiation as well. Okay, so in my scenario it is negotiating. Now how do I turn off? I just go to conf t configuration terminal. I go to interface giga 1/0 and I can just turn this off with the command. Let's try with no negotiate. Okay, it's not working. So let's try with switch port no negotiate. Okay, so when I take this down, so it says command rejected, conflict between negotiate, no negotiate, and dynamic status on this. Okay, so basically the other interface are listening. So I just need to do this on every interface. Okay, so let me see what is by default here. So this is 1/0. Okay, so it's going to give me first error saying that there is some conflict between no negotiate and dynamic. So let's see if I can turn that off with switch port mode dynamic. Okay, let's try with the okay, it's not going to be dynamic. I have to
So I think no negotiate auto.
that command didn't take.
Access first and then
Sorry,
no
No
nego.
negotiate auto.
no negotiate will not work on this particular switch.
You have to make the port access first.
Okay. Switch port mode access, and let's give a try now. Switch port no negotiate. Okay, so it took now. So it's now let's try to see the running configuration of this. Okay, and let's give a try by taking this down. Okay, so basically on this particular switch family, you need to have something running up. Okay, I would say when you configure access port, it is as equivalent as disabling this command. So I was expecting that without making use of this, the switch could have no negotiate, but I think that's the default behavior of this particular switch. Okay. So it says when I try to remove the access port, it will fall back to the negotiate command. This is how to be configured. Okay, negotiate, fine. Okay, so this is one way to remove the auto negotiation, that is by going to the access port. The second way to disable negotiation is by configuring a trunk. Okay, so if you configure switch port trunk encapsulation, Okay, let's see what is a negotiate here. Okay, so that is for a protocol negotiation. Okay, so let's say switch trunk port encapsulation dot 1q. So this will also disable your DTP negotiation. So let me write it here. How to disable auto DTP negotiation. One method, make this switch port as access mode. Second, make this as a trunk port. So if you enable this, your DTP will be blocked or your DTP will not negotiate. Okay. So let me see from this switch point of view, that is running on a IOU version. Show run interface E1/1 conf t. If I go to the first interface, let's say no, okay, this command don't work. Switch port no negotiate. Okay, so basically this has different commands. Okay, so if you see this, there is no negotiate command over here. Okay, if you see on IOVOS, so there is something for switch port no negotiate. Okay, so over here, to turn off the negotiation, you just can go to switch port mode access, or you can just go to switch port mode trunk and it will disable the auto DTP negotiation. And why do we need to disable the auto negotiation? Why don't we keep this auto negotiation? The reason is, let's say if these two are, or these two type of devices fall face to face, then the trunking will not come up. Okay, so we have to go to the manual process of converting them into access port or a trunking port. Okay, this is one reason. The second reason are some sorts of VTP attacks. Okay, so there are some sorry, not VTP attack, there are some DTP attack. And what who does that attack? So basically, let's say this is a switch which has DTP by default negotiating. Now let's say I bring one more switch. Okay, and if I just connect them, what is going to happen is there will be a trunking between these two switches by default. So once they are exposed to the trunking, once the DTP has been formed, so anyone who is connected behind this switch will have access to all the VLANs running on that trunking. So by default it will be that by default the trunking will be enabled for all the VLANs. So if you see this command, show interface trunk, so you can see by default the VLANs, all the VLANs will be considered. So these are some DTP attacks. To refrain such kind of scenarios in the network, what we do is we turn off the DTP completely from the network environment. Okay, so how do we do is either make use of the proper trunking or a access port, and rest which are not used or which is not getting used, just put them into access mode. Okay, so by doing that, what happens is there is no way someone connects to that and gets gets into the auto DTP mode. Okay, so you can convert to access port and just assign that to the parking VLAN, which we discussed in our workbook, where you can put a access mode and you can put in a VLAN 999 so that nothing will happen here. Okay, so this is one kind of attack which we see this. And how do we prevent is, so let me just write it down. So the one way of preventing is convert the port into access port and put into 999 VLAN. Let's say that is a parking VLAN or a parked VLAN with a suspended state. Okay. And the second way would be put them into a proper trunking. So you can make use of .1q. So this way we can disable the DTP. Okay. Now regards to one last thing over here, that is the two modes. Let me tell you what basically is happening here is dynamic desirable and dynamic auto. Okay. So in dynamic desirable, those switches which by default run on dynamic desirable will listen for the new DTP packet, as well as they will send the DTP packets to the other switches. Whereas in dynamic auto, they will only listen. Okay, they are going to just listen. They are not going to send anything. So this is the outcome. This is why when you have two auto and auto, they will not form trunking. The reason is the devices or the interface which is on a auto, they will never send something. Okay, so as good as, let's say I have two switches and I just connect them. So let's say if they are they by default are configured on a auto mode, auto DTP mode. Okay, by default what they do, they only listen. Okay, so if there is no one who can send any DTP packet, so how are they going to become a trunk first of all, right? Because they are listening, so that some listening for some DTP packet. But in this diagram, I don't have any switch which is sending. They are both are listening to they are just trying to listen that I get some DTP packet, but no one is sending it, right? So that is why when you have two auto, they don't form DTP. When you get desirable, let's say this get changed to desirable. Now this interface will start sending the DTP packet, which is listened on this, and then they form trunking. Okay, so if you have desirable on one side and you have auto in one side, other side, they will form a trunking. So that is the technical concept of these two mode. Okay, fine. So let me once check if I covered the things here. So I have the notes over here. So I have discussed about the features. The three modes are over here. Yeah, you can also call the switch port access mode as the fourth mode, but that is not a part of DTP. Okay, so that is why I have not mentioned access port here. Okay, I have the combinations. So it's your dynamic auto and dynamic auto which have a bad impact on the network. Okay, rest are good. They will either form access or they will either form trunking. There will be some communication. I mean they will form trunking, and all other scenario they will form trunking, but it's only your dynamic auto and dynamic auto when they will never form trunking. Okay, what is a DTP configuration? So if you are already on a DTP auto, or if you are already on dynamic desirable and you want to change the behavior, you can change this to a dynamic auto. Similar way, if you want to configure a dynamic desirable, you can just go to that interface and you can change that. Okay, and then this is the command to check the trunking behavior of this interface, of the interface. Okay, so as I told you, you will see the mode auto. Okay, let me do one more thing. Let me show you when the two switches are been on a hard coded trunking mode. Okay, so in that case, this mode will be turned off. We will see some other mode over here. So as of now, we will see auto, we can see desirable, but in the case of when they are both on a trunking, the mode will be different. This is negotiating on 8021Q trunking status. Okay, so the mode of statically configured trunk is on. So that is why I said when we have two trunking, so let's configure trunk between these two switch port. Okay, so I have switch number 7. Let's go to interface 1/0. Let's say switch port trunk encapsulation .1q. So when I'm hard coding the trunk, I have the privilege of taking .1q. Otherwise, I would have been forced to use the ISL protocols, right? Which is a bulkier in nature, which takes more of header space. Switch port mode trunk, switch port allow trunk VLAN, trunk allow VLAN. Let's say I'm allowing 99 and 100. Okay. Similar way, I go to the second switch, conf t interface gi1/0. I say interface trunk encapsulation .1q, switch port mode trunk, switch port trunk allow VLAN 9900. Okay, now let's see the trunking status. See, now it got changed to on mode. So when you have two trunking, that is manually configured, so when you have the manual configured trunks, they are going to be under on state. Okay, in your DTP it will be either auto or it will be desirable. As of now it is on a on mode. You have the encapsulation, they are not negotiating. If they negotiate, you will see a prefix with n hyphen, so n is for negotiating. Okay, the trunking and the native VLAN. So let's see from this interface switch port point of view. So when you open up this, you will see that your mode of administration is trunk, operation mode is trunk. Okay, encapsulation is .1q, and again the operational trunking is .1q. Okay, trunking is still on in case this trunking is nothing but between the two trunks. Okay, so in case of this switch port where we have a desirable configured, so you can see they are enabled. It's a dynamic desirable and it's forming a trunk relation and it's in a negotiate. And what is the encapsulation? Is .1q. In our case, it's it's ISL in case of auto negotiating, whereas we hard code or we manually code something, we can take .1q. Okay, fine. So what else is here? We discussed about DTP no negotiate. So this is a valid command on some platform. We can make use of switch port no negotiate. Okay, so let's see if I can disable no negotiate here. Show run interface gi0/0. I think it was here. Do show run interface gi1/0. Okay, now let's, okay, it's no negotiate already. Okay, fine. So how do we get this back? So if I take it out from a trunk, switch port negotiation, okay, let's say if I take this, or if I just default this configuration. Okay, so the negotiation will come back once again. So if you take back from access port or a trunk port, the DTP will start working once again. So you just have to make sure you put them in a access mode and assign to some non-usable VLANs, like some parked VLANs or something. Okay, so this is to disable the trunk, this command will show you how to disable the trunk. So as of now it is switched on. Okay, so if I want to disable that, I'll go to gi0/1 switch port access or switch port mode access, switch port no negotiate. So now you can see it's been disabled. Okay, regarding the attacks that we can see here are related to the dynamic or the auto DTP negotiation. Okay, so basically these DTP packets are unauthenticated, so they are not going to be password protected or something. So whatever you are sending across on your DTP, it's a plain text of data. So let's say, let's talk about this, or either we can talk about this. So I mean to say the DTP packets are unauthenticated, they are not password protected. Okay, so if anyone connects one more switch here and take the advantage of running DTP, okay, let's say his switch start operating on a DTP trunking, and let's say he have some computer with some Wireshark, he can take the control of all other VLAN. He can have access to a computer or a server which is over here running on a different VLAN. So we need to cut down that behavior. We don't want the trunking should be enabled by default. So the best option is change this, or make it no DTP. Okay, you can disable the auto negotiation property of this switch port either by making it to access, or you can put it into trunk in case if you really okay. So that way we can avoid this. We can avoid the attack number 1 of unauthenticated packets. Okay, you can just run this command, and the best practice is that have it fixed. Okay, either you can make use of access port or a trunk, but don't keep uh, the DTP negotiation. And there is one more way.
Just one more.
Yeah.
Just to add one more practice by few of the enterprises that they keep all unused ports in shutdown mode.
Okay.
That is few of, yeah. Few of the organization for as internal audit or external audit. So if it is up and it is disconnected, it will get as triggered as an alarm.
Okay.
So
Okay.
that if it is not used, you keep it shut down.
Okay. Yeah. So let me just tell you what exactly that means. So let's say if there is a interface which is not used. Okay. So let me say it is a unused. So I can shut this down. Okay. But before shutting down, what you can do is you can put this into access mode and put this in a non-used VLAN. So let's say I am making this part of access VLAN 999. Okay, and yes, you can shut this on. Otherwise, if you keep this under this, then it's as good as like non-usable. Okay, fine. So these are the ways we can shut an interface, either by bringing that to some different VLAN or by shutting down this. Okay. Regarding the attack number 2, I will show you one way to create some VTP attacks. Okay, so I'll just take some different lab. So let's say I have one server which is called as a Kali Linux. So with the help of Kali Linux, we can impose some layer 2 attacks. So I'll also keep this switch coming up. So let's say this is a good switch. This is a good network protection switch, and it's by default running on a DTP negotiation. Okay, I have not taken care of what we just discussed of putting it under shutdown or changing that to some other VLANs. Okay, uh, other VLAN or a access mode. I have kept it still in a DTP negotiation. Now, someone with little bit of knowledge on some triggering some attacks or something. Let's say he bring one more switch, a switch where he has the DTP enabled, okay, and behind the switch he has some computer where he's running some Linux server or something, okay. Now what can he do? I mean, can he do? What he can do is he can start sending some VTP packet, sorry, DTP packets, okay. Now when he send a DTP packet, even though this switch was in a auto state, or let's say it was in a desirable state, they will form a DTP negotiation. They will form a DTP neighbors. Now, by default, all the VLANs are allowed on this. So that is an advantage from this point of view. Now he is connected to some other computer. He can make use of that all VLAN access. He can cause impact on your servers or any other users, okay. So I'll just show you how this could be done very simple, how this attack could be done very simple with very less knowledge on these attacks, okay. So I just need the server coming up. I can send some uh, false DTP packet and the switch will start negotiating with that, okay. So that is why it's best way, uh, it's always advised to turn off the DTP, okay. You can turn off the DTP either by making access port or a trunk port. Okay, so let me take the terminal here. So when I open this tool, which is inbuilt inside Kali Linux, I can run lot of attacks from this tool, okay, like CDP, DCP, .1Q, .1X. So I have a DTP attack also. So to launch this attack, I just have to click here. I will see some predefined option to send some DTP packets, okay. If I click OK, my server is going to send any kind of DTP packets that can bring other device into negotiation, okay. I can send auto packet, I can send a desirable packet, I can send a trunk auto also. Now let's see from this switch point of view. So they started already in a auto negotiation, okay. So we see it started already in a DTP auto negotiation. And why is it taking .1Q at this moment? Because my false server sent a trunk in a .1Q encapsulation. That is the reason it started taking up in a .1Q negotiation, okay. So this was easy for me to put this switch into such negotiation, okay. And now by default I have access to each and every all the VLANs, because trunking is about carrying multiple VLANs, and from here I can send my packets to other users on other VLANs. So how can I avoid this? So as we just came across few options, I can first either shut down this. I can also put this under switch port mode access. So by doing this, my trunking will be getting disappeared, okay. So let's say show interface trunk. So now there is no trunking. let's see from this point of view if I can send some attacks once again. So if I send some attack, so you can see it is off now. The DTPs are off. And let's see from the switch point of view. So there is no trunking. Okay. So that makes your switch better, right? Otherwise, your switch would have negotiated for some DTP packets and now it would have been a victim. So by making use of a simple thing, by taking this, and now you can also turn it off by shutting down. So if I shut down this, then basically this will also not be reachable. Okay, so that is why I didn't shut it down. So now if you initiate, there will be actually no outcomes. So you can see there is no trunking. So this is how we just turn off the trunking, turn off the DTP packets. So why do then this DTP was introduced if it was all meant to just disable? So what is the usage of DTP? So as I told you, it is plug and play. Okay, let's say you are running on a lab environment, you need a trunking enable. So by default, you can just power on these two devices, and on a DTP negotiation, the two switches are going to be on a trunk. I also have seen some scenarios where some older servers which has to run on a trunking, but what happens in server is the server will be not negotiating on the protocols. Okay, so in that scenario, in case I have a DTP negotiation, so this interface can form a trunk with some older servers. So in that case also the DTP plays an important role. But yes, most of servers are nowadays put into access mode, and also servers that comes with trunk port will have a option to set .1 queue. Okay, now it's very less chances that a server needs to have some auto negotiation parameters, so we don't deal with this. So these are some outdated ones. But yes, when we have some server which run under auto negotiation, so from my switch point of view, I can put them in DTP so that by default they negotiate and we have the trunk reachability between a switch and a server. So apart from this, I don't see the actual benefit of DTP. So a lot of company take take the risk of taking this down. Okay, they just disable the DTP, they don't use DTP. Okay, fine. So that ends this topic. So let me know if you have any question, or if you have any past experience that you want to share regards to DTP, or any challenge that you encountered by having this on your network.
Just to share, I've never seen a DTP being used in a enterprise network.
Yes, yes,
So generally it is advised is to manually configure everything, because switching is the area which is more prone to causing outages and human errors, especially with the trunking ports or the STP configurations, right?
yes,
That is where a lot of possibility for human errors, and that's why every organization is very cautious with that.
yeah, true.
So the best practices is the best practices is any change once it is gone production, that has to be reviewed and approved.
Yeah,
And
so
script needs to be
even
created
have
before and then.
not seen any DTP running. The
Yeah,
only thing is every syllabus from CCNA to CCNP, you have this DTP getting
yeah,
introduced. So that is a very
yeah, right.
strange thing about the Cisco syllabus.
Yeah, I mean there are many things which are there in the syllabus which are not being used on a production network from a security aspect or compliance aspect.
Yes.
Sagar, I have a question for you. What is the static and dynamic trunking protocol?
Static and dynamic trunking protocol.
Yeah.
So static is when you manually configure a trunk. So when you manually configure a trunk on a .1 queue or ISL, we normally call it as a statically way of configuring trunk. And the other one which you said, dynamic, is what we just covered today. That is a DTP way of making a trunking.
Okay. I see.
Yeah. So that is what, like trunking we can enable either automatically with the help of DTP or manually by all the process of encapsulation, allowing VLANs, all those things. Okay, I was trying to find out the answer for this. If negotiate is enable, we can't change duplex. So let's see, because I don't think that is related to that. Okay, so as of now, this interface is on negotiate. Okay, it's down. So first let me bring that up. Okay, so it's come up, it's on static mode. So let's change the behavior to no switch mode. Okay, now it went to dynamic auto negotiate. Okay, now let's see if I can change duplex here. Okay, it says auto negotiation enabled, duplex cannot be set. So let's see what is that auto negotiation. Okay, so let me first make it into some access port, and now let's give it a try. Okay, so this is not that auto negotiation. Okay, this is not a DTP auto negotiation. Duplex cannot be set. Switch port.
I will try putting no negotiation auto. It will disable.
Okay. So this is a different auto negotiation. Let's give it a try. So I have enabled this.
So that negotiation is for the interface.
Yeah, that is
Yes, this interface.
that is a different auto negotiation, and DTP negotiation is different. Yeah, so I'm just trying a way to get this interface negotiation also. Okay, let me first try over here. Negotiation auto duplex. Okay, so this command.
So do no negotiation auto.
Okay. Okay, finally it worked. So this negotiation is different. I guess this is the interface negotiation. So let me take down this. Okay, so as of now, I have mode, access mode, no negotiate, and no negotiation auto, and duplex is half. So this deals with your DTP negotiation, this particular no negotiate, and the negotiation, this deals with your interface negotiation on a speed, on a duplex. So these are two different parameters here. So your DTP don't have anything to deal with the duplex. Okay. So when we have two interfaces, so I'll tell you what exactly is happening when we have two interfaces. So let's say these interfaces are capable of auto negotiation, full negotiation, and half negotiation. Okay. So we are talking about duplex now. So in case of full duplex, we can send and we can receive the communication at a time, whereas in a half duplex, it's always once it's sent, then the next person is going to trigger his side of communication. So that can be set under auto negotiation. So when once it's set up on a auto, by default they will negotiate, and let's say they both negotiate on a full, they'll start working on full. So this is a different negotiation which had to be turned off to enable the half duplex property. Now in today's class, what we discussed was the DTP negotiation. Now that is a different negotiation, that is from the operation point of view. Okay, that's the operation point of view, where we can enable these trunking features, all those things. I hope I'm not confusing. So one negotiation deal with the speed, the term negotiation, this is dealing with the speed of your full duplex to half duplex. The second negotiate was from the operation point of view. Okay, in terms of converting a switch port automatically in a trunk. Okay, now these two are different concepts. Here we are talking about flows. Over here we are talking about sending multiple VLANs. Trunking is multiple VLAN, access is sending of a single VLAN. Okay, so we can see two types of negotiation under the interface. So fine. So actually I have done with the class. So the next topic is ether channel, which I don't think I can cover up today. So I'll take this in the next class. So if you guys have no doubts, we can wind up for the day. If you guys have any doubt, then do let me know.
Sorry, in the previous class, you said something is not working on EV and GNS3. You said it's working on the packet tracer. What was it?
Okay. So you say okay. You mean to refer to the point where I talked about that packet tracer?
Yeah.
Okay. So that was in the scenario of VTP, where I said when I have three switches connected one below one, and I said that let's say the first server is running on a VTP server, the second one on a transparent mode, and the third one on a client mode. Okay, so when you do this lab over on EVNG and EVNG or GNS, you will see the behavior. You will not see the actual behavior of transparent. Okay, so what is transparent meant to do when server is sending something to transparent? Transparent is going to advertise those VTP packets to client. But in GNS and EVNG on the iOS that I am using, it was not advertising. The transparent was not advertising. But the same lab, when you do
okay.
when you do on a packet tracer, then you can see the role of transparent, where you can see transparent will advertise the packet. So that was what I covered, saying so in case if you're doing a lab and if you don't see,
I only saw that is not
Sorry.
Yeah, I only saw that it's not working.
Okay.
I only saw that it's not working. I tried it on GNS3, it wasn't working. Then on EVE is working.
Okay.
Initially, I thought it's not working. And I
Okay.
realized that the problem was that the VTP password were different. That's why it was not working.
On
Because
on
I had
EVNG,
to ask
on
the
EVNG or on GNS?
No, on EVNG.
Okay, so you mean to
It's
say
working.
EVNG it started working?
Yeah, it's working.
Oh, okay. Because
Maybe they.
okay.
I don't know what was you were doing.
Okay, so
But what I'm saying is that when I also thought it's not working, only to realize that I had different VTP password.
okay. So which iOS version are you using? Are you using the same GNS switch iOS version, or are you using something else in EVNG?
It's IOSV. I'm using IOSV. I don't know, that end is 2017 or something.
Okay, because
IOSV.
I tried on this version
QEMU.
VIOS.
Mm.
So this version on
Yeah, I'm using this. This is the same.
Okay, but on
That I'm using on
EVNG I didn't see
I just
this to be working. Yeah.
pardon?
No, I mean to say the same version, the same iOS. I have it on GNS and EVNG. It didn't work on both of them, and then when I went to the packet tracer, the packet tracer worked for me. So on a packet tracer,
Hey, that's what I'm saying.
yeah.
For me, I use the same. I think this is the same version that I use on EV, and it's working. I only realized that it's not working on GNS3.
Okay. Okay.
Maybe you need to go and try.
Yeah. Fine. Okay. Okay, so regarding to this layer 2 attack, as of now it's not required, but if it comes to the CCNP enterprise, then I'll let you know. Okay, so that is why I have not introduced this in our main topology. So basically this is a CCNP security, CCNA security for what we use this. Okay guys, so let's meet up in the next class. Okay, I'll cover up might be one or two topics in the next class. Okay, have a nice day and see you soon, everyone.
Okay.
Okay, bye, take care.